If you need to build a highly scalable web application, then one of your goals is to keep the threads in your server process as busy as possible. In an environment like ASP.NET, there are only a limited number of threads reserved for processing HTTP requests. And if these threads have to wait for a long input-output operation to complete, you end up with those threads sitting idle and doing no work. The classic example of this is a controller action that needs to call another web service, an I/O operation, to produce a result. A web service call that travels over the network, we often measure that in milliseconds, and if a web service call takes 250 milliseconds, then the processing thread has to sit idle for 250 milliseconds. If all the threads are tied up and idle, then any new HTTP requests that are arriving at the server, ASP.NET will queue them up and force them to wait for one of these request processing threads to free up. In previous versions of ASP.NET MVC, if you wanted to keep your threads busy, you needed to inherit from the async controller base class instead of the regular controller base class. Then you needed to split every action into two parts. The first part would kick off the long-running I/O operations like calling a web service by initiating asynchronous operations and providing callbacks for when the operation's completed. The second part of the action would be notified when all the async operations were complete, and then it could put together a result like a view result for the framework to consume. So here's the source code where the first part of the action, the index async, would instantiate some web service clients and kick them off asynchronously. It would provide callbacks so that when the calls return, it could take the results and put them in a view model, and then we communicate with the async manager in ASP.NET MVC3 to tell it how many operations are outstanding and how many operations are complete, and when all the operations are complete, it will automatically call index completed and pass in whatever parameters we specified so that we could render a view. Fortunately, all that stuff is gone. With ASP.NET MVC4, it's much easier to keep our request threads busy without introducing all of this artificial complexity. We can free our threads up from running long input-output operations, and I want to make clear what we're going to talk about in this module is asynchronous behavior on the server. What we're going to cover has nothing to do with AJAX or asynchronous calls on the client. The client has no idea what's happening on the server, and these asynchronous features have no visible impact on the client's request, except in some cases it might speed things up. So this module is all about keeping server threads busy, and to understand how easy it is in MVC4, we first need a little bit of background on two other topics, the task parallel library and the async and await keywords in C#. We'll start with the task parallel library.